Uh, Good evening, everyone. So today we start. The heading is force per unit length. Force per unit length for parallel wire. So suppose we have to infinitely long. We have to infinitely long current carrying parallel wire. Current carrying parallel wire. Let the current is I1. Let the current is I2. Elementary length DL. Elementary length DL. We know two things very well. We know two things very well. One, we know from the previous class, force is ILB. That is the first thing. And second thing is the magnetic field or infinitely long current carrying conductor wire is mu naught I by 2 pi y. Is it clear? Anyone, is it clear? Hello.
Yes, sir.
So if it is clear, now see if y is the if d is the separation between the two wire. So if we want to calculate, let it be first wire, let it be the second wire. If we want to calculate magnetic field due to the first wire and on the second wire, so we can use current in the second wire. So we can use it cross. Similarly, for this one, if we want to calculate the current in the first wire, we can use it dot. Okay, everyone. Can we say that due to this one,
Yes, sir.
magnetic field 1, and due to this one C, so magnetic field in this one is dot. Now, if we use Fleming's left-hand rule, my cross is the magnetic field, current is the this direction, so force is in this direction. So this is the direction of force. So we can write force at 2 due to 1. This is the second wire, and due to y 1. Why? Because magnetic field due to the first wire. Similarly, see this one dot. This is my dot out of the page. This is my magnetic current upward, and the force is this type. So I can write it this. So at 1 due to 2. So is it okay, everyone? You understand up to that?
Yes, sir.
So if up to this is okay, if up to this is okay, now see. Now see. Important note, some important note from first one. Okay, now we understand these are the objective questions. I mean, if we have two parallel wire, current carrying parallel wire, and current are in the same direction, force is attractive nature. And if the current carrying conducting wire, force are in opposite direction, current are in opposite direction, sorry, current are in opposite direction, then force is attractive nature. Sorry, force is repulsive nature. Is it clear? See, I'm in the same direction, force is attractive nature, current are opposite direction, force is repulsive nature. So this is one type of question they can ask you. One type of question they can ask you. Third question, they can give you a string. And then they say if the I is the current flowing through this, if I is the current flowing through this, then what happened in the wire? It is a compression or expansion. See, as the current flow in the string like this, so it will be flow like this, current flow like this. Now, as the current flow like this, so these two are the direction of current, which is same direction. So same direction means inside the string, what happened? will feel a compression, yes or no?
Yes.
And one more very important question. Examiner can ask you, suppose this is my magnetic field. In presence of this magnetic field, if we introduce a loop like this, okay, and that, suppose this is my direction of, so then they can ask you what is the shape of the conductor. See, first finger into the page, current. Oh, sorry. See, first finger, this current, this force is which direction? Force is outward. As the force is outward, force is outward. So what shape is, slowly it will look like a circular shape. Why? Because at circular shape, they exactly balance each other. Yes or no? Yes or no? Hello?
Yes, sir.
So up to this, is it okay, everyone? You write all this part?
Yes, sir.
Sir, এখনই দাঁড়িয়ে।
হ্যাঁ, ওই জন্যই জিজ্ঞেস করলাম।
Sir,
Done?
yes, sir.
Now see what happened. So if you want to find out force, at one, if you want to find out force at one, force H2 due to one, force H2 due to one, that is current I2 dl V1. So I2 dl, what is the value of V1? Mu naught I1 2 pi d. Similarly, if we find out force at 1 due to 2, so we can write I1 dl v2. So what we have, I1 dl mu naught I2 by 2 pi d. So mu naught I1 I2 dl by 2 pi d, but I1 I2 2 pi dl. So force per unit by d, force per unit by dl by, इसलिए हम लोग फोर्स पर इसको जल्दी जल्दी नोट डाउन करो तो। Suppose type 1 type 1. So many type of numerical is there from that part. Two questions are there. Question number 1, two current carrying conducting wire, carrying current 10 ampere, 20 ampere, and the separation is 10 centimeters. Separation is 10 centimeter. Find the point, find the position where net magnetic field is 0. Field is 0. This is the first question. Second question is same question. Now current are opposite direction. Same 10 centimeter. 10 ampere, 20 ampere. Same question. Find the position where the net magnetic field is 0. You understand the question? This is 10 centimeter. Centimeter. This is also centimeter. Okay, everyone. Here the same direction current flow. Here the opposite direction current flow. Find the position where the net magnetic field is 0. Hello. Am I audible? Hello. See, for the first question, see, this side is cross. If we use this point field, so this is the cross and this is the, sorry, this is the, for B1 cross, and for B2 the point is dot, right? So we can suppose let x is the distance, x is the distance from here, so that distance is 10 centimeter minus x. So if we say B1 is equals to B2, if we say B1 is equals to B2, so mu naught I1 by 2 pi x, mu naught I2, 20 ampere, sorry, 2 pi 10 minus x, mu naught cancel, 0 0 cancel, 2 pi cancel, 10 minus x is 2x, 10 equals to 3x, x equals to 10 by 3 centimeter. Done, everyone? Understand? Hello? Hello?
স্যার একটু বড় বড় লিখিও স্যার, এখানে বোঝা যাচ্ছে না অত ভালো করে। আচ্ছা এবার ঠিক আছে।
2 pi x. ঠিক আছে?
হ্যাঁ স্যার একদম ঠিক আছে স্যার।
So mu naught cancel, 2 pi cancel, 0 0 cancel. So 10 minus x is 2x, 10 equals to 3x. ঠিক আছে?
হ্যাঁ স্যার।
লিখে নিচ্ছিস?
হ্যাঁ স্যার লেখা গেছে স্যার।
সম্পূর্ণ লিখেছিস?
হ্যাঁ স্যার।
ওকে। চলো এইভাবে কারেন্টলি মাসি টাং বাজিয়ে দিচ্ছে। ধর্মের নামে মানুষকে ইন্ডিকেট করে। Okay. Now 10 ampere, 20 ampere. If you have current in opposite direction, the point is always either right side or left side. See, if we choose either left side or right side, we choose towards the small strength. So 10 ampere is small, we choose that side. Now see, if we see that this is the point where the net magnetic field is 0. So for this dot and for this cross, so this is the point 1 and 2. We can say magnetic field due to 1, magnetic field due to 2, mu naught into 10 2 pi, let the distance is x, that is mu naught into 20 by 2 pi, 10 plus x, mu naught cancel, 2 pi cancel, 0 cancel. 10 plus x is 2x, 10 equals to x. Done. দেখতে পাচ্ছিস এবার?
Yes, sir.
Okay. Next.
Hi.
হ্যাঁ,
স্যার খুব কেটে কেটে যাচ্ছিল আওয়াজটা, আমার নেটওয়ার্ক প্রবলেম আছে, স্যার আরেকবার এক্সপ্লেন করে দেবেন?
দেখ এটা ফার্স্ট ওয়্যার, এটা সেকেন্ড ওয়্যার, যদি অপোজিট ডাইরেকশন থাকে you choose the point always towards the small strength. So 10 ampere is less than 20 ampere, so we choose in the 10 ampere side. And if the current are opposite direction, either right side or left side, if the current are in the same direction, it is in between. So as they are opposite direction, we choose the left side because of the small strength. মানে small strength যেদিকে থাকবে সেই দিকটা চুজ করবে। তাহলে এখানে P পয়েন্টে ডিউ টু 1, P পয়েন্টে ডিউ টু 2. So magnetic field due to 1 and magnetic field due to 2 equal, then and only then 0, because opposite direction. 1 এর জন্য কত হবে? Mu naught I by 2 pi x, mu naught I by 2 pi, 10 plus x, এবার I1 কত হচ্ছে 10, I2 কত হচ্ছে 20, কাটাকুটি করলে এটা আসবে, ঠিক আছে? 10 সেন্টিমিটার, তাহলে x কত হয়ে গেল? ক্লিয়ার?
Yes, sir.
Okay, after that type 1. Now that type 2 is type 1 এর পরে type 2 হচ্ছে যে suppose this is infinitely long current carrying conducting wire, carrying current suppose 10 ampere, and P is a point which is at a distance 10 centimeter. Okay, suppose a positive charge moving with velocity, the charge is 10 to the power minus 3 coulomb, moving with velocity 10 to the power 4 meter per second. Find the force applied on the charge particle. Find the force applied on the charge particle. কত হবে বল? So first of all, see, as this is my current, so magnetic field is cross. What is the value of D? Mu naught I by 2 pi x. If we want to find out the value of mu naught is 4 pi 10 to the power minus 7. Current 10 ampere. 2 pi x 0.1, 10 centimeter means 0.1 meter. So what we have, 2 into 10 to the power minus 7, 10 to the power 2, that is 2 into 10 to the power minus 5 Tesla. What is the direction? Cross. See, cross. Now you have cross is the magnetic field, velocity is this, so force is in which direction? This is the direction of force applied. So force is QVB cross B, QVB sine 90 degree, because the velocity vector and force 90 degree to each other. So QVB, you can write directly QVB. Charge is given 10 to the power minus 3. Velocity is given 10 to the power 4. Magnetic field we find out 2 into 10 to the power minus 5. কত হয়ে গেল তাহলে? 2 into 10 to the power minus 4 Newton. Now the direction দেখো, if this is my east, this is my west, this is my north, this is my south. So the force is acting towards the west. So we can say west. Yes or no? Is it okay, everyone? Yes?
Yes, sir.
লেখা হয়ে গেছে? সম্পূর্ণ লিখেছিস?
হ্যাঁ স্যার লিখে নিয়েছি।
Now the next type of question, type 3. I just show you each type of question one, huh? One from each type. They just change the data. Next question is an infinitely long current carrying conducting wire, suppose 10 ampere, and you have a rectangular loop. This is 20 centimeter. This is 10 centimeter. And suppose the current is flowing like this. This is 20 ampere. That distance is 10 centimeter. So I can do one thing. How I can calculate the net force applied in this one? See, these two are balancing each other, same magnitude, opposite direction. From here, the magnetic field is also same. Each and every point magnetic field is exactly same for these two wires. So the force due to this two wire is equal and opposite. Now, if you suppose this is the first wire, this is the second part, this is the third part, we know if the forces are in the same direction, they are attractive in nature, and if the force is opposite direction, they are repulsive in nature. So these two forces are attractive in nature. So I can write force as 2 due to 1. And what I have to find out, we have to find out net force applied in this wire. As we have to find out net force applied in this wire, we don't need to calculate the force in the long wire. Similarly, if we see this one, 1 and 3, that see this 1 and 3 are in opposite direction. So force is repulsive nature. Here also it is repulsive. But ek pe mujhe nahi chahiye. I don't need to write for 1. We just find out the force at 3 due to 1. Now, if we calculate force at 2 due to 1, देखो अभी थोड़ा देर पहले हम लोग फोर्स पर यूनिट लेंथ का बात किया था, म्यू नॉट I1 I2 by 2 pi d. यहाँ पे पर यूनिट लेंथ इसलिए लिखा था because that wire can be infinity. But if you see that length of the wire, that is not infinity, that is 10 centimeter. So to find out force, I can directly write I1 I2 2 pi d into dl. Can we write this directly, this formula?
Yes, sir.
So on that basis, for mu naught, I can write 4 pi into the power minus 7, current 10 ampere, current 20 ampere, 2 pi for this one, D1, this distance. My separation is 10 centimeter on a 0.1, and DL, my length is how much? 10 centimeter. So this cancel. So what we have, this cancel. So what we have, 2 2s are 4 into 10 to the power minus 5 Newton. Now similarly, if you want to calculate this wire, force at 3 due to 1, 4 pi 10 to the power minus 7, 10 and 20, 10 and 20, 2 pi. That distance is 20 plus 10, that is 30 centimeter. That means 0.3. And that length is 10 centimeter and is 0.1. So what you have, 2 pi cancel. So 2 to 4, 4 into 10 to the power minus 5 by 3, because you can cancel this is 3. So what you have, 4 by 3 into 10 to the 5 minus 5. Now it is very clear that force of 2-1 and force of 3-1, force of 2-1 is greater than force of 3-1. So force net, force of 2-1 minus force of 3-1, 10 to the power minus 5, 4 minus 4 by 3. 12 minus 4 by 3, that is 8 by 3 into 10 to the power minus 5. Done. Everyone, is it okay?
Yes, sir. স্যার বলছিলাম এটা কি টাইপ 2 এর না টাইপ 3?
Type 3. Type 2 তো আগের বার হয়ে গেল। Type 3. अच्छा, अब देखो force of 2-1 and force of 3-1 में बड़ा कौन सा है? Force of 2-1 is greater than force of 3-1, so net force is applied towards the infinity long one. So you can write towards the infinitely long wire. Clear? Everyone, is it okay?
Yes, sir.
Type 4. Okay, now type 4. ঝালাপালা করে দিল। Type 4. शीशा हो दिल किसी का, let this current is I1 and you have a conducting wire where the current carry is I2. This length is A and this length is L. Yeah, B. Find the force applied in this conducting wire. Next type. This is type 4. So how can we solve this type? See, we can imagine a small elementary length dl, which is at a distance L from the wire. So what is the magnetic field at that point? Magnetic field is R. You can write also R. So then this is dr. Mu naught I 2 pi r, that is my magnetic force here. Force का formula क्या था? Force का formula था I2 is my current. This current is I1. So I2 dr, because instead of L I use yes, dr into B. Is it clear, everyone? Can we write this? For magnetic field is mu naught I1 by 2 pi. Mu naught I1 by 2 pi r. So force is I2 dr B. Can we write? Can we write? Hello, can we write?
স্যার তুমি কি ডিএল এর জায়গায় ডিআর লিখছো?
হ্যাঁ, ডিএল এর জায়গায় ডিআর লিখলাম কারণ এখানে আর ভ্যারিয়েবল, তো তাহলে এটাকে এল লিখতে হতো। মিউ নট আই বাই 2 পাই আর ই আমরা লিখে আসি, এটাকে আর করে এটাকে ডিআর করে দিলাম। ডিআর ডিএল একই তো, স্মল ছোট পার্ট একটা।
ঠিক আছে।
So what happened? I2. Acha, this force is also then df because for small elementary part. So I2 dr. What is my dr? Dr is dr, and this B is mu naught I1 by 2 pi r. So if I arrange it, mu naught I1 I2 2 pi r dr. So to find out total force, to find total force, taking integration both side df 0 to f mu naught I1 I2 2 pi 1 by r dr a to a plus b. Is it okay? This is my one end, this is my another end. This end is a, this end is a plus b. So f is equals to mu naught I1 I2 2 pi log of r a to a plus b. So mu naught I1 I2 2 pi log a plus b minus log a. So f is equals to mu naught I1 I2 2 pi log a plus b by a, which is f is equals to mu naught I1 I2 2 pi log 1 plus b by a. Is it okay? Okay. Is it okay?
Yes, sir.
লেখা হয়ে গেছে?
স্যার এক মিনিট। হ্যাঁ স্যার হয়ে গেছে।
সবার হয়ে গেছে লেখা?
হ্যাঁ স্যার।
আমি দিয়ে দেবো, এটারও নোট কালকে শুরু। ছেড়ে দেব না। So this is the inner point, this is the outer point, and in between this, a wire is wounded like this. Okay, total number of wire is N. Total number of wire. A is the inner radius, B is the outer radius. I is the current. Find magnetic field LD field at the center. High five. তোমার হৃদয় মাঝে রাখবো, ছেড়ে দেব না। Okay. Anyone tell me what is the answer? what is the answer? See, let in this question, suppose we are take a wire whose radius is r and thickness is d and y, because n is the total number of turns. So, sorry, thickness is dr and the total number of turn is dl. So, number of turn for elementary length dr is, तो dr में number of turn कितना होगा, dn. Try to understand. मेरा total number of turn कितना है, n, yes or no? 1 2 3 4 5 6 7 8 9 10 करके n. ये thickness मेरा कितना है, total number of turn per unit b minus a and the thickness, total number of turn by total length b minus a and the thickness dr. Is it clear, everyone? Everyone, is it okay? Hello.
স্যার আরেকবার বুঝিয়ে দেবেন?
দেখ এখানে কি হচ্ছে, n নাম্বার অফ টার্নস আছে টোটাল, আমি ধরে নিলাম এই পুরোটাতে n নাম্বার অফ টার্ন আছে. উই কনসিডার a single wire whose radius is r and let the thickness is dr. So first we try to calculate the number of turn in that dr length. So dn is the number of length, dn is the number of wire with that small thickness dr. How can we find out this? Total number of turn n by total length b minus a into the thickness. Total number of turn by total length into thickness, we get the number of turn within that thickness. Yes or no?
Okay, sir.
So magnetic field due to that dB, magnetic field due to that is mu naught I to the length is r, because we know magnetic field due to a circular coil is mu naught I 4 pi r into 2 pi from the last to last class, that is mu naught I by 2r, and here the number of turn is dn. So I can write it mu naught I, মানে মনে করে একটা টার্ন, তাহলে একটা ম্যাগনেটিক ফিল্ড যদি তিনটে টার্ন হয় তাহলে ম্যাগনেটিক ফিল্ড মাল্টিপ্লাইড বাই 3. That means if the number of turn is n, so my magnetic field is multiplied by n. Okay, so mu naught I by 2r into n by b minus a dr. So overall what happened, n mu naught I to b minus a dr by r. So if we take calculation, is it okay? So taking integration both sides to find out total magnetic field, 0 to magnetic field n mu naught I to b minus a integration of 1 by r dr from inner pole A to the outer pole B. Clear? Is it okay, everyone?
Yes, sir.
So now if we integrate this, এটা লেখা হয়ে গেছে?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
So integration of this one is b, that b is equals to that B is equals to N mu naught I by 2 B minus A log R 1 by R dr is log R A to B. So N mu naught I to B minus A log B minus base C log A, that is N mu naught I to B minus A log B by log A AC. Okay. Okay. Okay.
Yes, sir.
Acha, I want to give you one more type of question. একই টাইপের কোশ্চেন একটু ডিফারেন্স। ওকে, তাহলে এগুলো সব কোশ্চেন হয়ে গেল তোদের, বলতে পারবি। The last question is, suppose examiner given you two wire, same like the previous one, 10 ampere and 20 ampere, and suppose this distance is 20 centimeter, and now examiner say at the middle point, see this is not the point where the net magnetic field is zero. Try to understand, this is a little bit different question. The question is that at the middle point a charged particle is introduced with some velocity v. The charged particle is 10 to the power minus 3 coulomb, and velocity of the charged particle is 10 to the power 4 meter per second. Find the force applied on the charged particle. Find the force applied on the charged particle. So see, last time we try to equalize this and make it the net position 0, but now as it is a middle, so that is 0.1 meter, that is also 0.1 meter. Let this is magnetic field 1, this is magnetic field 2. This magnetic field is into the bridge B net B, that is B1 clearly what clearly cross B2 clearly dot, B2 clearly dot. Is it clear, everyone? At P, cross and dot, yes or no?
Yes, sir.
So now mu naught I is 10 ampere by 2 pi, that distance is 0.1, this is cross, plus mu naught, that distance is 20 ampere, 2 pi into 0.1 dot. So what you have, 4 pi into the power minus 7 into 10 by 2 pi into 0.1 dot. 4 pi 10 to the power minus 7, 20, 2 pi 0.1 dot. That means I can cancel this, I can cancel this. So 2 into 10 to the power minus 5 Tesla cross 4 into 10 to the power minus 5 Tesla dot. Clearly it is visible, 4 is greater than 2. So 4 minus 2 is 2 into 10 to the power minus 5 Tesla dot. What do you mean by dot? Dot means this is my magnetic field. বাইরের দিকে, my velocity of the charged particle, force applied towards the east. Force applied towards the east. How much is the force? QVB. Charge is how much? Charge is how much? 10 to the power minus 3. Velocity is how much? 10 to the power 4. Magnetic field is 2 into 10 to the power minus 5. So what we can write? 2 into 10 to the power minus 4 Newton towards east. Got it? Is it okay?
Yes, sir.
So that's it for today. অনেকগুলো টাইপ করলাম, 6টা টাইপের নিউমেরিক্যাল করলাম, আর অল্পই বাকি আছে, অল্প মানে আছে। From the next class we start